Hi everyone and welcome back to the channel. So in the last update, we got this locomotive to operate on the 9-volt track using an old redundant 9-volt motor that wasn't able to run anymore. We used it basically as the wheels for the pickup to power a power functions motor that we installed at the front of the train. We controlled that using this old Lego 9-volt controller. So what we're going to do now is get rid of that and use this Arduino and this Arduino motor shield to drive the 9 volts to the track. And how we do this, just before I go on, I'll just let you know that this is the power supply for the Arduino. This is the power supply for the 9-volt motor shield. They've both got independent switches under the counter and they both come from external 5-volt power supplies and a 9-volt power supply. So let's get into it and we'll see how you connect these up. So if we can just get that in focus. Sorry for the shaky camera work there. So this is our positive. Our orange is our positive 9-volt or 5-volt supply to the Arduino. And as you can see, that goes into V in. The yellow is our negative and that goes to ground. So as soon as you have 5 volts on those two pins, you've got an Arduino that's powered up. Other ways to power this up, you can use a standard 9-volt power supply connection here. And when you power the USB, when you connect the USB to it to program it, it also powers up the Arduino. So to basically get this Arduino, this 5-volt Arduino, to drive the 9-volt train, we have to switch this 9-volt supply via this motor shield, and we switch that by telling the Arduino what to do with the motor shield. So to connect up that, what we have to do is we have to connect our motor shield to the pins, and I've just used pins 1, 2 and 3. If you can see the PWM, we need one of our pins to be a PWM pin, and in this case it's pin number 3 on this Arduino. So if we go over here, I'll just move that out of the way, we can see our 9 volts positive and negative connected in. We have an ENA, and that's the blue wire, and that's connected to pin 3 on the Arduino. And then we've got IN1 and IN2, and they are the grey and the purple, and they're connected to pins number 1 and 2 on the Arduino. And then we basically have another 2 wires bringing 9 volts out of the motor shield and across to the track. So this is an old faulty 9-volt connector that I have, and if I take that off, you can see that it's loose and it's not making too much connection, not making good connection. So I have that clamped in place using these bricks. I have it joined here just using some heat shrink, and that's basically all the connections that we need to make to get this controller to make this train go. Once I have 5 volts on this Arduino and 9 volts going in here. Now at the moment you'll see a green light on here. The 5 volts is on the Arduino, but the 9 volts is switched off for the motor shield, so nothing will happen. Now if I switch on the 9 volts from the switch underneath the table, the train will go. But in order to make that happen, we have to write some code and send it to the Arduino. So I'll show you what that is now. So once you download the Arduino IDE, as they call it from the internet, you can Google Arduino IDE and you'll be able to download the program for free, and that will enable you to program your Arduino. So what you do is you create a new sketch, that's what they call the programs, and to do that, once you open up Arduino IDE, you can do File, New, and it opens this window. So you've got this, it gives you a date, it gives you a name for it, and then it has void setup that you set up your code and void loop, and when you put whatever you put in void loop is your program. So we'll just open up a new window here and start putting in our program. So this is our program to make the train run. As you can see, I've changed the name of it to inner loop 1, we've got our 3 pins that I outlined earlier in the video. So 1, 2, and 3, and the track power PWM pin is pin number 3. So once we have those identified, we go into the setup and we say that they are all output pins. And it is very important that you use these semicolons, etc., and the brackets and the case of the text as you're putting in the code. And then in the void loop, we have analogWrite ENA 240. Now, the ENA, that value can go from 0 to 255. 0 is off, so there will be no power going to the track. 240 is nearly at maximum, and that's the equivalent of turning the dial on, say, the Power Functions remote control. And then digitalWrite IN1 and IN2, that's basically saying to have IN1 on high, so 9 volts out. digitalWrite IN2 low makes pin number 2 0 volts. So that basically means that one track is 9 volts, one track is 0 volts. And if I was to make those both low, nothing would happen because there'd be 0 volts on each track. If I was to make them high, again, nothing would happen, but it wouldn't be an advisable thing to do. And then if I want to change direction, what I do is I make IM1 high and IN1 low and IN2 high. But for this demonstration, we're just making the train go in one direction only. And what we'll do is we send that to the Arduino. So we plug in to the USB port from our laptop, and then we press this button here, which basically checks the code for errors. And it compiles the sketch. It's done compiling. And then we make sure that we're connected to the Arduino. And at the moment, we're not. So what we'll do is we'll connect up the USB into the Arduino, and I'll show you how that works. So now we have the Arduino connected to the laptop. And as you can see on the screenshot here, we have got our port as identified as COM7 with an Arduino Uno connected to it. So once we have that, we're ready to upload the sketch to the Arduino itself. And we do that by pressing the upload button here on the top of the screen. And because this is such a small program, it'll upload, and it's done uploading already, as we can see. So that's basically it, guys. That's the program written and then uploaded to the Arduino itself. So it's now ready to work. So this is our cable connected to the Arduino for programming. So we can disconnect that. And that is the Arduino fully programmed, the motor shield connected and ready to power the track using an external 9 volt power supply and an external 5 volt power supply. So once we switch on the power to the motor shield, the train will run again. And just before I do that, I just want to let everybody know to check out the Arduino for Lego Trains channel. Without that channel, I would never have been able to do any of this, and I really recommend anybody who wants to know more about this kind of motor control and how to operate Lego 9 volt trains or even Power Functions trains. He has tutorials on that channel that are absolutely fantastic, and I'd never be able to do this without having checked that out. So we'll just turn on the power to the motor shield now, and we'll see our new train running. Oh, and next time around, we're going to get this train to stop in this passing loop in order to switch the points each end there and there in order to let the other passenger train run on the same track in the opposite direction. That's going to take a while. But yeah, so that's it for this update, guys. And until the next time, see you later.